Assalamualaikum and salam sejahtera. Welcome back to KMKK official channel. In this session, we will going to learn about subtopic 3.2 NERNST equation and subtopic 3.3 electrolytic cell. This session will be presented by Puan Munira, and at the end of the session, you will be provided with QR code as your attendance. So, I would like to invite Puan Munira to continue this session. Okay. So, Puan Munira.
Okay, thank you, Puan Ismawati. Okay, Assalamualaikum and good morning to all students. Okay, today we are going to discuss chapter 3, okay, which is electrochemistry. So for today, okay, we are going to discuss subtopic 3.2, which is NERNST equation. Okay, for the learning outcome, okay, at the end of this topic, okay, students should be able to, okay, first write okay. NERNST equation. Okay, NERNST equation is used to calculate the E cell at not at standard condition. Okay, E cell not at standard condition. Okay, this formula. Okay, E cell equals to E naught. E naught cell minus RT over NF ln Q. Okay, which is Q equal to the concentration of product divide by concentration of reactant. Okay, T is a temperature in Kelvin. Okay, R is a gas constant which is 8.314. F is a Faraday constant. Okay, 96500 coulomb. And N is a number of electron transfer. Okay. Okay, NERNST equation can also be written in terms of logarithm. Okay, if we want to use a logarithm formula, okay, we can substitute, okay, 2.303, okay, this formula. So we can derive the formula when we substitute R constant. Okay, substitute the R constant. Okay, we substitute the temperature at 298 Kelvin and the value of Faraday. Okay, so the formula will become E cell equals to E naught cell minus 0.0592 over N log. Okay, the formula will become log concentration product divided by concentration of reactant. Okay, so this formula can only use when at 25 degrees Celsius or 298 Kelvin. Okay. Okay, so we go for next slide and we will see a example, the question. Okay, so this is example. Okay, the question is, okay, calculate the E cell for the following cell. Okay. Calculate E cell for the following cell. Okay, so the question given, okay, the question give a cell notation. Okay, this is cell notation. Okay, from previous lecture with 1 Shafinas. Okay, you have discussed about this cell notation. Okay, from cell notation, okay, we also have half cell of zinc and we have half cell of copper, and also we have a E naught cell. We have E0 oxidation and we have value E0 for reduction. Okay, so to calculate the E cell, first we must calculate the E0 cell. Okay, calculate the E0 cell. Okay, for calculate E0 cell, okay, we have two formula that we can choose, whether the formula E0 cell equals to E0 reduction plus E0 oxidation, or the other formula is E0 cell equals to E0 cathode minus E0 anode. So depends lah. Okay, so for the first formula, if we use the first formula, so E0 reduction, okay, from zinc is positive 0.76. E0 reduction is copper, okay, positive 0.34. Okay, plus the value of E0 of oxidation is positive 0.76. So plus we will get the E0 cell positive 1.10 volt. Okay, if you want to use the second formula, okay, so E0 cathode minus E0 anode. Okay, for cathode is reduction is copper. Okay, so we take the value 0.34. Okay, value for cathode. But for anode, we must change the sign of the value because this value is for oxidation. Okay, if you want to use the formula, the value must reduction. So we must change the sign from positive to negative sign. Okay. So you will get the same answer lah, positive 1.10 volt. Okay. Then after we have a E0 cell, okay, we continue, proceed for the formula. Okay. Proceed the formula. Okay, E0 cell, center. Okay, the formula we use is 0.0592 divided by N. Okay, N. What is the value of N? Okay, the value of N from this equation. Okay, back to previous slide. Okay, N is number of electron transfer. Okay, zinc lost 2 electron and copper gain 2 electron. Means that the electron transfer and electron gains equals to 2 lah. Okay, the value Sn equals to 2. Okay, log concentration of zinc 2 plus divided by concentration of copper 2 plus. So from question given, okay, just substitute the all values. So we will have the answer for each cell is positive 1.139 volt. Okay, so the cell reaction is spontaneous because its cell value is positive. Okay. Okay, next. Okay, what happened at equilibrium? Okay, at equilibrium means no net reaction occur. So Q equals to K. Okay, when E cell equals to 0, okay, so E cell equal to 0, so the formula will become E0 cell equals to 0.0592 divided by N log K. Okay, so log will become log K lah, because the reaction is at equilibrium. Okay, example question. If the reaction at equilibrium, okay, example the question given. Okay, calculate the equilibrium constant K for the following reaction. Okay, if the question mention equilibrium constant K, so means that reaction is at equilibrium. Okay, so from this reaction, we must determine first, okay, which cell undergo oxidation. Okay, which cell is undergo oxidation and reduction. Which cell undergo oxidation and which cell undergo reduction. So from this equation, copper become copper 2 plus. So copper undergo oxidation. So oxidation occur at anode. Okay. For silver, okay, silver plus becomes silver. So silver is a reduction because the oxidation number decrease and reduction occur at cathode. Okay. Okay, so first, okay, we will calculate the E naught cell. Okay, we use a formula. Okay, first formula or second formula depends. Okay, E naught cathode minus E naught anode. Okay, refer SRP table, standard reduction potential table. Okay, so E naught for cathode, okay, which is silver. Okay, you get the value is positive 0.8. And refer the SRP table. So for anode is copper. So the value we will get is positive 0.34. So the E naught cell value, so we will get the value is positive 0.46 volt. Okay. Okay, so we proceed this formula to calculate the K. Okay. We want to determine the value of K. Okay, from this formula, E cell equals to E naught cell minus 0.05 minus 2 over, okay, 2 is number of electron transfer when we balance the equation and log K. Okay, E cell equals to 0. Okay, substitute the E naught cell 0.46. Okay, so we will get the value of K is, okay, so it's 3.467 times 10 power of 15. Okay. Okay, so okay, next we go for the electron, like electrolytic cell. Okay, electrolytic cell. Sorry, ada technical problem. Okay, we continue. Sorry for the technical problem. Okay, continue our lecture. Okay, so continue our lecture. Okay, next, okay, we will discuss about electrolytic cell. Okay, the learning outcome. Okay, at the end of this topic, okay, students should be able to draw an electrolytic cell, describe the operation of an electrolytic cell, explain the influence of the following on the selective discharge of the species at electrode. Okay, the first one is SRP of the species, concentration of the species, nature of electrode, whether the electrode is active or inert, and okay, predict the electrolysis of following electrolyte using inert electrode. Okay, so we have electrolysis of molten salt. Okay, we have electrolysis with water. Okay, we have concentrated or diluted. And we predict product of electrolysis using appropriate example. Okay, we go for the next slide. Okay, electrolysis. Okay, what is electrolysis? Okay, electrolysis is a chemical process that uses electricity for a non-spontaneous redox reaction to occur. Okay, such reaction takes place in electrolytic cell. Okay, electrolytic cell. Okay, electrolytic cell it is made up of two electrode immersed in an electrolyte. Okay, direct current is passed through the electrolyte from an external source, and molten salt and aqueous ionic solution are commonly used as electrolyte. Okay, this is electrolytic cell. Okay, from this slide we can see there are two electrodes immersed in electrolyte. Okay, so from the left side we have anode. Okay, anode is a positive terminal, and at the right side is a cathode. Cathode is a negative terminal. Okay, electrode. Anode is electrode which connected to positive battery. Okay, connected to the positive terminal of the battery, and the cathode is an electrode which is connected to negative terminal of the battery. Okay, so anode which is oxidation takes place, and cathode which is reduction takes place. Okay, so we also have electrolyte. Okay, electrolyte is a liquid that conduct electricity due to the presence of positive and negative ion. So we have positive and negative ion. And anion will go to anode, and cation will go to cathode. And electron flow, okay, we can see electron flow from anode to cathode. Okay, this is a electron flow. Okay, this is electrolytic cell. Okay. Okay, this one. Okay. This explanation about electrolytic cell. Okay, so electrode and electrolyte. Okay, electrode is as a circuit connector. Okay, example, we can use platinum or graphite and electrolyte. Okay, liquid that conduct electricity due to the presence of positive and negative ion. Okay, must be in molten state or in aqueous solution so that the ions can move freely. Example is potassium chloride or hydrogen chloride. Okay. Okay, as electrolysis cell is used electricity, okay, so battery is used as source of direct current that force electron from anode towards cathode. Okay, during electrolysis, okay, anion move to anode and give their electron and become oxidized to atom. Okay, at the same time, cation move to the cathode and gain electron and become reduced to atom. Okay, those oxidation reaction takes place at anode and reduction reaction takes place at cathode. Okay, you must remember this. Okay, this is how cell for anode, cathode, and the overall cell reaction. Okay, this one. Okay, this is a comparison between an electrochemical cell and electrolytic cell. Okay, electrochemical cell. We have learned from previous lecture with Puan Shafina. So, the difference. Okay, we can see the difference between electrochemical cell and electrolytic cell. Okay, so you can see electrolytic cell, okay, use electricity, and electrochemical cell or galvanic cell, okay, generate electricity. Okay, another difference, okay, the terminal for anode, for electrolytic cell, okay, anode is a positive terminal, and for electrochemical cell, okay, anode is a negative terminal. Okay, for electrolytic cell, okay, cathode is negative terminal, and for electrochemical cell, cathode is positive terminal. Okay. Okay, so for electrolytic cell, okay, we only have one electrolyte. Okay, this one electrolyte, and two electrode immersed in electrolyte. And for electrochemical cell, okay, we have two electrolyte, and we have salt bridge. Okay, this is salt bridge. Okay, so for electrolytic cell, so no need salt bridge. And electrolytic cell, we have a battery. So for electrochemical cell, so no need battery. Okay, and electrolytic cell is non-spontaneous and electrochemical cell is spontaneous reaction. Okay, so you can see this difference between galvanic cell and electrolytic cell. Okay, so next, okay, we will see the similarities. Okay, what is the similarities between these two cells? Apa yang sama? The similarities. Okay, the similarities of these two cells. Okay, oxidation occur at anode, reduction occur at cathode. Okay, anion move towards anode, cation move towards cathode. Okay, electrons flow from anode to cathode in an external circuit. Okay. Okay, next. Go to, okay, we want to predict the product of electrolysis. Okay, so from electrolysis, we have, okay, three type of electrolysis. So we have molten salt, We have dilute aqueous solution and we have concentrated aqueous solution. Okay, okay, there is a factor influence the product. Okay, the first one. Okay, the reduction and oxidation potential of the species in electrolyte. Okay, we can refer the standard reduction potential table. Type of electrolysis. Okay, first we go to electrolysis of molten salt. Okay, molten means no water. Okay, no water. Okay, so electrolysis of molten salt require high temperature. Example, electrolysis of molten sodium chloride. Okay, electrolysis of molten sodium chloride gives sodium metal deposited at cathode and chlorine gas involved at anode. Okay, this electrolysis of molten sodium chloride is industrially important. The industrial cell is called down cell. Okay, from this slide we can see the electrolysis of molten salt. Here the electrolyte of molten sodium chloride. So we only have chlorine minus as an anion and we have Na plus as a cation. Okay, only these two ions in this electrolyte because no water present. Okay. Okay, at anode, okay, oxidation occurs. So anion will move to anode and oxidize, and cation will move on. Okay, chlorine gas and sodium solid. Okay, this is overall cell equation. Okay, this is a product for molten salt. Okay, so for molten salt, which is easier to choose the product because we only have one anion and one cation to be choose. Okay, next electrolysis is aqueous salt. Okay, electrolysis of salt is more complex. Okay, because the presence of water molecule. Okay, aqueous salt solution contain anion, cation, and water. Okay, water. So we have ion OH minus and H plus. So anion, cation, OH minus, H plus from water. So water is an electroactive substance that may be oxidized or reduced in the process depending on the condition of electrolysis. Okay. Okay, this is an equation for water reduction and oxidation if water is select for the product. Okay. Okay, reduction. At cathode, so if water is selected, so hydrogen gas will be produced at cathode and oxygen gas will be produced at anode. Okay. Okay, first we go for the diluted aqueous. Okay, diluted means cair. Okay, tak pekat. Okay, so we have cathode, we have cation Na plus. Okay, Cl solution we have Na plus and Cl minus. Okay, cation and anion. Okay, so for cathode, cation Na plus will move to the cathode. Okay, and water molecule also. Okay, so from E0 value, okay, which one to be selected? Okay, E0 for water molecule is more positive. Okay, H2O is easier to reduce. So H2O will be selected for the cathode. Okay, for anode, okay, anode, anion will be move to the anode. Okay, Cl minus and water molecule. Okay, so in dilute solution, okay, water will be selected for oxidation because of its lower enol. Okay, so at anode, okay, we choose the lower enol. Okay, at cathode, okay, we choose the enol which is more positive. Okay, so for anode, we choose water. Cathode, water, and anode also water. So this is a reaction involved at anode and at cathode. Okay, cathode H2O, here will produce the hydrogen gas, and at anode H2O will produce the oxygen gas. Okay, to balance the equation, so the equation must multiply by 2. So we will get a 4 electron for the left side and 4 electron for the right side to be cancelled. Okay, so this is the overall cell equation. And when we have 4 mole hydroxide ion and 4 mole hydrogen ion, H plus ion at the same side, so H2O will be formed for H2O. Okay, to be nicer for equation, so we simplify by cancel 4 more electron at the right side, 4 more from the left side, so this we get only 2H2O from the left side. Cancel 4 sebelah kanan, cancel 4 sebelah kiri, so H2O akan tinggal 2. Okay, so this equation is simple. Okay. Next, we go to concentrated. Okay, concentrated mean larutan yang pekat. Okay, nak tengok apa beza produk yang akan terhasil. Okay, same sodium chloride but concentrated. Okay, concentrated aqueous sodium chloride. Okay, sodium chloride aqueous solution contain Na plus ion, the cation, and Cl minus ion, the anion, and water molecule. Okay, so on electrolysis, the cathode attract Na plus ion and H2O molecule, the anode attract chlorine minus ion and H2O molecule. Okay, those Electrolysis of aqueous sodium chloride depends on the concentration of electrolyte. Okay, why cathode attract Na plus not Cl minus ion? Okay, as we know, cation will move to cathode and anion will move to anode. Okay. Okay, for cathode, okay, we have Na plus and water molecule. Okay, so E0 for water molecule is more positive, so H2O easier to reduce. Okay, same as diluted, water molecule is selected. Okay, for anode, okay, because this is a concentrated solution. Okay, for anode, okay, in aqueous solution, chlorine will be selected for oxidation because chlorine has high concentration and the rate of oxidation of chloride ion is faster than the rate of oxidation of water molecule. Okay, so at anode, chlorine gas will be selected. Okay, that is a difference between diluted and concentrated electrolysis. Okay, this is a reaction involve half cell cathode, half cell anode. So for cathode, H2O will be selected, anode, chlorine gas, and overall cell reaction. Okay, so from calculation, so we have the inert cell is negative 2.19 volt. Okay, next example. Okay, okay, next example. Okay, if we use a platinum electrode. Okay, platinum electrode is an inert electrode. Okay, inert means not active lah, tak aktif, electrode yang tak aktif. So we will see what is the product to be selected. Okay, so sodium sulfate aqueous solution contain Na plus cation and sulfate ion anion and water molecule. So cathode attract cation Na plus ion and H2O molecule, and anode attract anion and H2O molecule. Okay, for cathode, okay, for cathode, you can see, okay, water molecule is more positive compared to Na plus. Okay, so for water molecule is more positive, so H2O is really easier to reduce. Okay, water discharge at cathode. Okay, for anode, okay, sulfate. Okay, the sulfate cannot be oxidized because sulfur is in highest oxidation number, which is positive 6. Okay, oxidation number dia tinggi. Therefore, H2O is oxidized. Okay. This is for inert electrode. Okay, at cathode, water, anode also water. Okay, cell. Okay. Equation for cathode and anode and cell reaction overall. Okay, cathode, okay, hydrogen gas. Cathode hydrogen gas is produced and solution become basic at cathode because hydroxide ion are formed. Hydroxide ion. Okay, at anode, oxygen gas is produced, oxygen gas, and solution become acidic at anode because, okay, we have H plus ion. Okay, this is a product when we use an inert electrode. Okay, so take note kat sini. Okay, anion that are not oxidized include, okay, ion fluorine F minus, sulfate, nitrate because it is already at the highest oxidation number. So ion ni can oxidize lah. Okay, another example. Okay, from this slide we can see, okay, electrolysis of aqueous copper sulfate using inert electrode also. Okay, using inert electrode. Okay, anion will move to anode. So this anion. Okay, cation will move to cathode and water molecule. And also the water molecule will go to anode and will go to cathode. Okay, which one will be selected? Okay, copper and water molecule. Okay, inert for copper is more positive. Okay, copper 0.34 compared to negative 0.83. So inert for copper is more positive. Those copper 2 plus will be selected to be discharged. Okay, copper for cathode. Okay, for anode, okay, water molecule is selected to be discharged because, okay, sulfate cannot be oxidized because sulfur is in the highest oxidation number, which is positive 6. Those water will be selected at anode. Okay. Okay, this equation for this house cell equation. House cell equation and overall. Okay, so the product you can see, okay, bubble of oxygen gas at anode and the blue color of copper sulfate solution fades. Maksudnya dia dah lah. Color copper sulfate tu color biru. Okay, so after reaction, so dia akan jadi color pudar. Okay, what will happen if we use active electrode? Okay, electroactive pula. Okay, apa jadi? Okay, produk apa yang kita nak select kat situ? How to choose the discharge ion at cathode and anode? Okay, active electrode. So, electrode yang kita guna kat sini adalah copper electrode at anode and also copper electrode at cathode. Okay, copper is active electrode. Okay, what happened? What happened from this electrolysis? Okay. Okay, we have copper electrode. Okay, anion and water molecule will move to anode. Cation and water molecule will move to cathode. Copper electrode to be considered to select because copper is active electrode. Copper is active electrode. So, at cathode. From E0 cell value, E0 for copper is more positive, those copper 2 plus will be selected to be discharged. Same as in the electrode lah. For cathode, for anode, because the sulfate cannot be oxidized because sulfur is in highest oxidation number which is positive C. E0 for copper is more negative, copper will be selected. So for active electrode and anode, copper will be selected. This is a product for active electrode. Hauser equation at anode copper and at cathode also copper. So the product copper electrode at anode will be decreased in mass and copper electrode at cathode will increase in mass. Anode decrease, cathode increase. The blue color of copper sulfate solution remains. Example. This one is example of electrolysis copper sulfate using reactive electrode. So this one is electroplating process. So proses penyaduran kunci Q. Kunci ni kita nak sadur dengan copper. So kita letak kunci ni sebelah cathode sebab kita nak sadurkan kunci ni dengan copper. So apa jadi nanti? Sebelah anode ni copper ni akan decrease lah. Mass dia akan decrease, so dia akan datang deposited dekat sini. So this is applied in industrial process. So this is a summary for the electrochemical cell and electrolysis cell. Next, sikit lagi. So ada Faraday's. We have Faraday's law of electrolysis and apply Faraday's law in calculation. For electrolysis, we have calculation which is Faraday. Faraday's law of electrolysis is describe the relationship between the amount of electricity passed through an electrolytic cell and amount of substance produced at electrode. So kita nak calculate lah berapa mass yang deposited. Faraday first law. Faraday first law state that the quantity of substance formed at an electrode is directly proportional to the quantity of electric charge supplied. So mass M is directly proportional to Q. Mass, quantity of substance, directly proportional to Q. Q is electric charge in coulomb and M is mass of substance discharge, and formula will become Q equals to IT. Q is electric charge, I is a current in amperes, and T time in second. We see the example for Faraday's calculation. Okay, before we go to calculation, okay, amount of substance formed at electrode may be calculated from stoichiometry of equation. And knowing that the charge on 1 mole of electron is 1 Faraday. So 1 Faraday equals to K96500 coulomb. Okay, this is a constant. Okay, so lithium, okay, Li plus 1 electron produce Li, okay. Okay, from this equation, we have 1 mole lithium. Okay, 1 mole lithium produced equal to 1 mole of electron equals to 1 Faraday. Okay, 1 Faraday because 1 electron and equals to 96500 coulomb equal to 6.9 gram. Okay, 1 mole of lithium. Okay, so ini perkadaran dia. Okay, ini for lithium is for 1 electron. Okay. So for magnesium, 2 electron. If 2 electron, so 1 mole of magnesium. Okay, 1 mole of magnesium. Okay, equals to 2 mole of electron. Okay, from this equation. Okay, 2 electron equals to 2 Faraday. Okay, so if 2 Faraday, so we must multiply. Okay, 96500 with 2. So for 1 mole magnesium, we have the mass deposited is 24.31 gram. Okay, so let's see the example question for the question. Okay, example A. Aqueous solution of copper sulfate is electrolyzed using a current. Okay, current use 0.15 ampere for 5 hours. So calculate the mass of copper deposited at cathode. So kita nak kira berapa mass copper yang deposited dekat cathode. Okay. Okay, so we apply the formula. So Q equals to IT. K I 0.15 ampere. Okay, time from 5 hours. So we must convert to seconds. So times 60 times 60 to change the time to second. So okay, so we get the electric charge. Q equals to 2700 coulomb. Okay, copper. Okay, as we know, 1 mole of electron equals to 1 Faraday equals to 9650 coulomb. Okay, number of electron passed through, we divide Q divided by Faraday. So we will get the number of moles from calculation is 0.028 mole. Okay. Okay, from okay, copper 2 plus. So we have 2 electron. Okay, 2 electron. From equation, 2 mole electron produce 1 mole of copper. Okay, from calculation, we only have 0.028 mole of electron. So we only have 0.014 mole of copper because we only have 0.028 mole electron. Okay, so to calculate mass copper deposited, okay, mole times molar mass of copper. So the mass is 0.889 gram. Okay. Okay, so that's all for today. Okay, these are electrolysis uses in daily life. Okay, you can read your note. And so, last one. Okay, don't forget to scan this barcode for your attendance for today's lecture. Okay, so thank you.